Hey guys, I'm not going to be there with you today. However, you're going to continue your work with similar triangles and you're going to work with word problems today. We went over a couple on Friday, but I just wanted to refresh you on how we would do those. Hopefully, you've already received your packet from your sub that's with you today or a teacher that's on our hall. All right, so we're going to start with one that involves the sun. All right, so we're going to use shadows to find heights. So with those, we have using shadows to find the heights. Suppose you want to use the shadow method to estimate the height of a building, and you make the following measurements. So we have that the length of a stick is 3 meters. The length of the stick's shadow is 1.5 meters, and the length of the building shadow is 8 meters. So we're going to look at this. We have two similar triangles. We know that those two triangles are similar because we have that the sun rays, which would be coming down here and here, there's the same because the sun's in the same place in the sky. We also know that our shadow would be proportional on both. Obviously, the shadow of the stick is going to be much smaller than the shadow of the clock tower. All right, so here we go. We're going to look at how to set that up. And we have proportional things going on here. So our clock tower is what we're looking for. So that's going to be a measurement of X that we don't know. All right, so we're going to flip over here. I've got our triangles here. We have the height of the clock tower is labeled with a variable of H, and its shadow here is 8 meters. Similarly, the stick has a height of 3 meters and its shadow is 1.5 meters. So I'm going to set the height of the clock tower over the height of the stick, and that would equal the shadow of the clock tower over the shadow of the stick. We're going to use our cross multiplication method, just like we've been doing, and we would end up with 1.5h is going to equal 24. I'm going to divide both sides by 1.5, and I'm going to get that h is equal to 16. All right, now I can't leave that as just 16 because it's actually representing a height. So the height of my building would be 16 meters. I would want to write that out so that I understand what we have actually found, what it represents. All right, going back to our problem over here, we're going to pull up our mirror problems. All right, so on this problem, we have that the height from Jim's eyes to the ground is 150 centimeters, and the distance from the middle of the mirror to Jim's feet is exactly 100 centimeters. The distance from the middle of the mirror to the point directly under the traffic signal is 450 centimeters. So we're looking to find what the height of the traffic light is. All right, so we're going to come back over here to our problem. And we can see, using our mirror problem here, so you can see I've labeled it. We have similar triangles here. We know that when it bounces off the mirror, it creates similar angles. All right, and we know that Jim is exactly has a 90-degree angle to the ground, and we have one there as well. So by angle, we know that these would be similar triangles. All right, so we're looking for this height up to the traffic light. So we could do our height of the traffic light to the height of Jim from his eyes to the ground, 150. All right, and the distance from the traffic light to the mirror would be 450. And the distance from the mirror to Jim is going to be 100. So this one's going to give us a little bit larger. We're going to do some cross multiplication again, just like so. And we're going to have our 100h is going to equal, and we're going to take our 450, and we're going to multiply that by 150. That's going to give us 67,500. All right, so we're going to divide both sides by 100. Not sure if y'all remember this trick, but since it ends in double zeros, both of them do, we just kind of cross those out, and we would have the h would equal 675. Now, what does this 675 represent? Well, it represents the distance from the ground to the traffic light. And since it's in centimeters, it would be 675 centimeters. Okay? All right. All right, these are the next two problems we're going to look at, and you should have them in your packet. Move that one up so we can see it a little bit better. All right, but we're going to start here with the number 2. A bush is sited on the other side of a canyon, and that little thing's the bush. Find the width of the canyon. They've set up some similar triangles for us. I'm going to come over here to my sheet so that we can look at this a little bit better. And right there. All right, so you'll notice I've got number 2 right here. All right, so we have the bush and we have this canyon. This is the X. So we're looking for the distance from one side of the canyon to the other side of the canyon. All right, so we run along the distance here of the canyon. And then we put something out there just like the bush as well. So if we're 7.5 feet from the canyon, and that distance is 10, and we know the distance from here to here is 100, and the distance from across the canyon is what we're looking for, which is X. All right, so again, we've made 2 right angles with each one of these triangles, and we've also got a set of vertical angles here. So we know that these 2 triangles are similar by the theorem of angle-angle. So we can now set up similar proportions. All right, so the distance across the canyon is going to be represented by X, and the distance from where I'm standing to the river is 7.5. All right, the distance along the bank of the canyon is going to be 100, and the distance from where I'm standing to where the angles cross is going to be 10. All right, so you need to make sure that both numbers in the top would either deal with the small or the large, but they have to deal with the same triangle. So we have the X and 100, that's with the big one, and then we have the 7.5 and the 10, and that would be the small triangle right here. So we're going to do a little cross multiplication again. So we would have 10x and 7.5. So we're going to multiply that 100 by that 7.5 and the 10 by the x. So that's going to give me 750 would equal 10x. And we're simply going to divide by 10. And we're going to use that little trick again I just showed you, where you're just going to cancel them out. So 75 would equal x. Now what does that represent? Well, if we're coming back over here, X represented the distance across the canyon. So that would be 75 feet. Okay. All right. You're welcome to pause the video if you need to work on that problem real quick. All right. I'm going to come back to our PowerPoint now. And we're looking at the flashlight problem. And this one is a little bit different to understand and to see. So I wanted to go over it with you. All right, so we have a 12 centimeter rod is held between the flashlight and the wall as shown. All right, so I'm just showing you real quick. This would be our rod right here. All right, find the length of the shadow on the wall if the rod is 45 centimeters from the wall and 15 centimeters from the light. All right, so we're looking for the length of that shadow. All right, so we know, coming out here, I'm gonna change screens again. All right, so I've got this nice little drawing right here. Sorry, that's my turtle in the background. All right, okay, so, a little crooked there. All right, so we have our flashlight, and our flashlight is hitting the rod, and the rays from that flashlight are going to project onto the wall. So we're looking for the length of this shadow here. Now here's where it gets a little bit tricky, and it may help to draw 2 additional triangles. That way you can kind of see the similarity here. We know that in this small triangle, which is occurring right here, that the distance from the point to the rod is going to be 15 centimeters. And we know that that rod was just 12 centimeters. Now, the distance that this is creating here, because it's in the middle of the triangle, that's actually called an altitude. And an altitude is really the height of the triangle. All right, now we're going to look at this big triangle. And this big triangle starts here, and it goes all the way across and down like this. We know we're looking for that shadow, and I'm going to use an S because I'm looking for a shadow. Here's where it gets a little tricky. A lot of people just want to use the 45. However, the distance is from the flashlight all the way to the shadow. So you have to add the 15 and the 45 together, which would give you 60 centimeters, which was not actually given in the problem. It's something that you have to put together. All right, so we're going to start with our small one this time. We know that 15 centimeters is the distance from the flashlight to the rod. So that's our 15. Now we're going to go from the flashlight to the wall, which is representing the rod and the smaller one. So that would be 60. All right. Now, the rod was 12 centimeters, but the shadow is what I'm looking for. So I'm going to use that S. And be careful you don't make your S's look like 5s. Now I'm going to cross multiply. So I have 15S is going to equal, take that 12 and multiply it by 60, and that's going to give me 720. Now, again, this is your variable of S, so that's not 155. We're going to make sure we just divide by 15. All right, so we have that 120. We're going to divide it by 15, and we're going to get that our shadow is 48, and that's going to be in centimeters. Okay, so 48 centimeters. Okay. All right, the last one that I want to go over with you is right here. All right, so the foot of a ladder is 1.2 meters from a fence that is 1.8 meters high. The ladder touches the fence and rests against a building that is 1.8 meters behind the fence. Draw a diagram and determine the height on the building reached by the top of the ladder. All right, so we're going to go back to our notebook paper. All right, and we're going to come right back up here. Okay. All right, so we have a building and we have a ladder, and this little part here represents our fence. So we still have the 90-degree angles here, okay, and they are sharing an angle, and if you'll remember, when they share an angle, that's called reflexive property. So we essentially have two triangles here. We have the little one, where we have the 1.2, and we'd have the height of the fence is 1.8. But we also have this large one here. And sometimes it helps to break them up. All right, and we have a 90-degree angle. We're looking for the height that the ladder's coming up onto the building. All right, now the distance from the building to where the ladder's leaning is not this 1.8, and it's not just this 1.2. You're actually going to take that 1.8 and add it with that 1.2, and it's going to give you a total of 3. So 3 is going to be the value that I actually use. Not this one and not this one, but a combination of them both. So let's set up a ratio here. All right, so I have that this 1.8 here is going to go with that x. So I'm going to set up 1.8 over x is going to equal, and now I'm going to use my 1.2 and my 3. So I have 1.2 over 3. And I'm going to cross multiply. All right, so I'm going to have 1.2x is going to equal, and 1.8 times 3 is going to give me 5.4. I'm going to divide both sides by 1.2. Okay, and I have that x will equal 4.5. Now that means that this is going to be 4.5 meters. That means the ladder hits it from the ground to where the ladder rests on the building is 4.5 meters. Okay. All right, now let's talk about what we need to get done this week and what we need to get. All right, coming back to the PowerPoint. All right, so today is November 16th. I want you to work on this word problem packet. I do not expect you to finish it tonight. I do not expect you to have everything done today. I do want you to go through it, and I want you to get comfortable with doing them. I want you to draw them out, and I want you to work on them really hard. Remember, we agreed last week that we would pull the IXL and the Delta would be pulled on Wednesday. So that also needs to be a method of focus for you. Second thing is we are still going to quiz, and we're going to be using we'll either be doing paper or we'll be doing online. I haven't decided yet, but we're going to be doing a quiz that's going to involve the right triangles with geometric mean, which is our L and T, and we're going to use similar triangles with word problems. Probably going to do that on Wednesday, not Tuesday. Okay, I'm going to go ahead and change that. No, I can't right now, but yep, there we go. All right, so we're going to do that on Wednesday. Okay. And we plan to test on Thursday or Friday, no matter what. If you're going to be leaving for break earlier than that, please communicate with me so we can make individual arrangements. And you would need to do that by shipping me an email. So Stacy Smith at bannon.k12.ga.us is where you would need to send an email to. I hope to be back with you in person soon, but for right now, we're going to be virtual. I will be able to do Google Meets with you if we need a little extra practice or you need a little extra time with me. I hope to see all of y'all soon, and I'll talk to y'all tomorrow.